So hello guys, good day. I am here, Jan Russell Termulo, in front of you to present our topic, Internet Connectivity. So before we proceed to the next slide, the term Internet is derived from the word interconnection network, meaning the large network of computer networks connecting worldwide. Introduction. The Internet is a worldwide network of computer networks that connects university, government, commercial, and other computers in over 150 countries. There are thousands of networks, tens of thousands of computers, and millions of users on the Internet with the numbers expanding daily. Um, the Internet is the wider network that allows computer networks around the world run by companies, governments, and universities and other organizations to talk to one another. The result is a mass of cables, computers, data centers, routers, servers, repeaters, satellites, and Wi-Fi routers that allows the digital information to travel around the world. It's travel around the world and the world wide web, and therefore I can say that internet is everywhere and now everything. Why? Kasi syempre sa panahon ngayon, halos lahat ng bagay nakabase na sa internet. Data connection, internet, manood ka lang ng TV, minsan kailangan ng internet. Pag magse-search ka ng assignments, kailangan ng internet. Sa panonood mo ng Netflix, sa pag-Facebook, YouTube at etc. mag-Twitter ka, di ba? So yun guys. Next slide. The internet connectivity. The term internet connectivity refers to the way people are hooked up to the internet and may include dial-up telephone lines, always-on broadband connections, and wireless devices. Among these, wireless access to the internet is the newest and as of the early 2000s had only reached a small group of users. Broadband connections including DSL or digital subscriber line or NADSL, asymmetrical DSL, and cable modems were becoming more widespread but still represented a small percentage of internet users. A study by Nielsen Net Rating covering the year 2000 found that more than 85% of home-based users connected to the internet with ordinary telephone modems ranging from 28.8 kbps to 56 kbps. Only 6.4% had high-speed internet access, while 8.3% were still using 14.4 kbps telephone modems. So, since the early days of the internet, connectivity for the typical users has improved markedly by offering greater speed of the transmission and wider bandwidth to accommodate special services such as audio and video. In this consumer market, the first improvements were made in dial-up telephone connections, with modems increasing in speed from 14 kbps to 56 kbps, with the growth in popularity of the World Wide Web, or the WWW, and its ever-expanding stock of multimedia content that need for more bandwidth and higher transmission speed created new demand in the household and small business for broadband alternatives, which until that time were commonly only in large corporations, universities, and government agencies. Um, Dati pa yan guys, but ngayon, mas pinalaki na ang or mas pinabilis na ang speed ng internet dahil sa fiber connection or yung mga ginagamit ngayon ng PLDT. At ngayon guys, yung mga telecommunications is may 5G na sila technology. So, at next slide is the internet connection types. There exist several ways to connect to the internet. following are these connections type available. First is the dial-up connection. Second, ISDN. Third, DSL. Fourth, cable TV internet connection. Fifth, satellite internet connections. And last is wireless internet connections. Um, this time, I will pass the next slide to Miss Esperanza Antolin to explain what is this type of connection to the internet.
Next topic to discuss is the internet connection types. One of the internet connection type is the dial-up connections, the ISDN, the DSL, the cable TV internet connections, and the satellite internet connections. Last is the wireless internet connections. The first topic to discuss is the dial-up connections. So what is a dial-up connection? Dial-up connections uses telephone line to connect PC to the internet. It requires a modem to set up a dial-up connections. This modem works as an interface between the PC and the telephone line. There is also a communication program that instructs the modem to make a call to specific number provided by an ISP. So, ang dial-up connection is ito na yung pinaka-old technology na ginagamit pa noong 1990s. So, ang dial-up connections requires telephone lines sa mga bahay natin, and also requires and provides a modem. And sa modem na to, it's usually installed sa computer para yung computer maka-receive and send ng digital information over our phone lines. Next is the protocols using in dial-up connections. Unang protocol is the serial line internet protocol and the point-to-point protocol. So, anong pinagkaiba nung dalawang to? Ang SLIP is requires siya ng it does not require authentication, and while the PPP it does not provide authentications. Another difference is the SLIP data is transferred in a synchronous form, while in PPP data is transferred in asynchronous and synchronous form. The last differences of the two is the SLIP covers the Internet Protocol packet while the PPP covers the datagram. Next is the ISDN, or ISDN stands for the Integrated Services Digital Network. It established the connections using the phone lines which carry digital signals instead of analog signals. There are two techniques delivered in ISDN services. One is the basic rate interface and the primary rate interface. So what is the basic rate interface? Basic rate interface is one of the two levels of services provided by Integrated Service Digital Network. BRI is made from home and small scale of enterprise use. It consists of two bearer channels, which is the B channels and the G channels. Sa B channels, it carries the data, voice, and other services, while sa D channels carries controlling and signaling data. While the next is primary rate interface. Sa primary rate interface naman is an interface standard associated with a transmission of voice data over the dedicated line. PRI uses a secret switch mode for voice call among people located in different locations. PRI works at provides 23 versus channels that's business can use simultaneously at any given time. So key points, the BRI ISDN consists of three distinct channels on a single ISDN line. The T10 for 64 kbps, the B bearer and the B bearer channel, and 16 kbps for the D or the data or delta or data channels. Next is the PRI ISDN. As I have mentioned lately, it consists 23 B channels and 1D channels, with both have operating capacity of 64 kbps individually, making a total transmission rate of 1.54 mbps. The diagram below shows accessing internet using the ISDN connections. Next is the DSL. DSL is the acronym of Digital Subscriber Line. It is a form of broadband connection and provides connections over ordinary telephone lines. Following are the several versions of DSL technique available today. One is the asymmetric DSL, the symmetric DSL, high bitrate DSL, rate adaptive DSL, very high bit rate DSL, and the ISDN DSL. All of the above mentioned technologies differ in their upload and speed, bit transfer rate, and level of service. The below diagram shows that how we connect to the internet using DSL technology. In the diagram, if you connect to the internet, you might connect through a regular modem, through LAN connections in your office, through cable modem, or through the DSL modem connection. The DSL is a very high speed connection that uses the same way as a regular telephone lines. Next is the cable TV internet connections. Cable TV internet connections is provided through cable TV lines. It uses coaxial cable, which is a cable capable of transferring data at much higher speed than common telephone lines. Key points is a cable modem is used to access the service provided by cable operator. The cable modem comprises of two connections, one of internet service and other for is the cable TV signals. Since the cable TV internet connections shares a set of amount bandwidth with a group of customers, therefore the data transfer rate also differs on number of customers using the internet at the same time. Sa cable internet services uses the same coaxial cable network as cable televisions to provide your home with internet. First, your internet service provider sends a data signal through a coaxial cable and or a coax cable into your home, specifically to your internet cable to your modem. The modem then uses an internet cable to connect to the router, which is what gives you access to the high speed internet cable. Its internet service providers transmit data between the servers using the coaxial cable, and since TV itself takes up only a small portion of the cable's bandwidth, it leaves the room for internet servers to work within the same network. And the following diagram shows how the internet access using the TV connection. Next is the satellite internet connections. Satellite internet connections offers high-speed connection to the internet. There are two types of satellite internet connections. The one is one-way connection or the two-way, and the other one is the two-way connection. In one-way connection, we can only download data, but if we want to upload, we need a dial-up access through ISP over telephone line. In two-way connection, we can download and upload the data by the satellite, but it does not require a dial-up connection. The following diagram shows how internet can access using the satellite internet connections. Wireless internet connection. Wireless internet connection makes us use of radio frequency bands to connect to the internet and offers a very high speed. The wireless internet connection can be obtained by either Wi-Fi or Bluetooth. Wi-Fi wireless technology is based on IEEE 802.11 standard, which allows the electronic device to connect to the internet. Bluetooth wireless technology makes a short wavelength radio waves and helps to create a personal network or the PAN. Ang wireless connection, ito na yung ginagamit nating lahat ngayon sa kasalukuyan. Lahat ng ginagamit nating Wi-Fi or even Bluetooth, lahat na wireless. Sa communication ng wireless internet connection, is two-way. There's a transmitter and the receiver, and both of your computer and handheld devices at the piece of equipment such as a router that connects you to the internet. Ganun yung pag-work ng wireless internet connections. Ito na yung diagram of how to access internet using the wireless internet connections.
Internet-based communication. We know that the internet is a collection of connected network that transfer data via packet switching with the help of internet protocol, TCP and IP. Unlike before, people cannot connected to their friends, families, or relatives in any parts of globe while staying at home. Internet-based communication refers to sharing information over the internet. We have an example of internet-based communication: email, social network, and forum. Email is the original internet communication tools. Email is still an essential tool every business should have. Modern life and business has become easier thanks to the contribution of internet technologies. However, it was not created overnight. It took a long time until network could be connected together. From here, the network has had tremendous impact all over the world. The foremost target of internet has always been communication, and internet has excelled beyond the expectation. Now, we can communicate the fraction of second with the person who's sitting in the other parts of the world. So, what is internet? Internet is such an important thing nowadays. Most of us is every day, whether it's search for information, to find friend and event, to buy grocery. The internet is globally system interconnected computer network that interchanges data by packet switching using the standards internet protocol switch. We have an example of internet: web, email, and social media. Web, a collection of billions of web pages that you can view with a web browser. Why the internet was invented? The concept of internet, also called the World Wide Web, was developed in early 1970s by United States Defense Advanced Research Project Agency of DARPA. The agency launched a research campaign to find effective way to link computer to facilitate the exchange of information. When was the internet first introduced? ARPANET and adopted TCP/IP on January 1, 1983, and from there, research began to assemble the network to networks to become a modern internet. The online world then took on more recognizable from 1990, when computer scientist Tim Berners-Lee invented the World Wide Web. What is communication? Communication is the process of conveying information from a sender to receiver with the use of medium in which the communication information to understood by both sender and receiver process that always people to exchange information by several methods. We have a different categories of communication: verbal communication, non-verbal communication, written communication, visual. Verbal communication, which include face-to-face, telephone, radio, or other media. While non-verbal communication, we have a body language and gesture. Written communication, we have letters, email, social media, book, magazine, visualization, web graphs, and charts, maps, and logo. Who invented the communication? The telegraph revolutionized long-distance communication. The telephone meaning far sound is the most widely used telecommunication device. It was invented in 1876 by Alexander Graham Bell, with Thomas Watson Bell patented his invention of March 1876. Who is the father of communication? Professor Emeritus Claude E. Shannon, known as the father of modern digital communication and information theory, died February 24 at the Courtyard Nursing Care Center of Medford after a long battle with Alzheimer's disease. He was 84 years old. What is the advantage of communication through the internet? It was allow people to correspond with each other in a faster, more efficient, and often expensive way. We use email and instant message to keep in touch with families, members, friends, and perhaps even business associates. Sometimes we feel more comfortable conversing with people when we can see or hear them.
Hi sir, my name is Marisol Aguinaldo from BSIT 3-3 and I'm here to report about addressing in IoT or Internet of Things. What is addressing in IoT? Assumption. Target of this discussion is addressing for IoT or machine-to-machine services with IPv6. Those of IPv4 will use IPv4 private address. IoT or machine-to-machine service network addressing depends on the network structure. First, non-dedicated network, things connected to users network. Second, dedicated network connected to the internet. Third, IoT dedicated closed network. Fourth, non-IP networking IP gateway. First, non-dedicated network means different devices that connected. Second, dedicated network connected to the internet, only one that have been connected. IoT dedicated closed network, same with non-dedicated network, different device that connected. The last, non-IP network with IP gateway means limited devices that have connected.
Good day everyone, my name is Casey Apoya. I'm going to present current IPv6 policy. Current IPv6 allocation policy. Allocation criteria to qualify for an initial allocation of IPv6 address space an organization must be an LIR. LIR means Local Internet Registry. This is for provider services or internet users, not be an end site. This defined as end user na merong business or legal relationship na involved yung isang providers. Plan to provide IPv6 connectivity to organizations to which it will make assignments. Ito yung plan to provide IPv6 na connect sa isang organization ng isang network to make assignments. Meet one of the following criteria. Have a plan for making at least 200 assignments to other organizations within 2 years or be an existing LIR with IPv4 allocations from APNIC or an NIR which will make IPv6 assignments or sub-allocations to other organizations and announce the allocation in the inter-domain routing system within 2 years. Current IPv6 assignment policy. Assignment criteria. To qualify for an IPv6 assignment from APNIC, requesters must demonstrate their eligibility under one of the following 4 criteria. IPv6 for multi-homing. Multi-homing means the connecting host or computer network is connected hindi lang sa iisang network. IPv6 for critical infrastructure. This describes the physical and cyber systems and the assets. IPv6 for internet exchange points. Ibig sabihin, when the networks comes together to connect and exchange the internet. And the provider independent IPv6 assignment. Current IPv6 policy. Provider independent IPv6 assignment. Request for provider independent assignment must include a detailed plan of intended usage of the proposed address block over at least the 12 months following the allocation. Initial assignment. Organizations are eligible for an IPv6 provider independent delegation if they are able to demonstrate a valid reason that an assignment from their ISP or LIR is not suitable for guidelines on what will considered a valid technical or other reason. See APNIC guidelines for IPv6 allocation assignment request. Non-dedicated network. A non-dedicated network gives the policy of sharing the resources with other computers on the internet. Dedicated network connected to the internet. Dedicated internet connection is a connection that is dedicated to one users. IoT dedicated closed network. Para siyang private networks na hindi connected sa public internet. Non-IP network, IP gateway. As you can see, the non-IP devices connecting siya sa IP gateway na nagsisend ng local network. Summary addressing of IoT M2M service network. Addressing depends on the network structure. Type IoT service network. Number 1, non-dedicated network. Things connect to users network. Dedicated network connected to the internet. Can IoT service providers obtains IPv6 address? IoT dedicated closed network. PI, ULA, ULAC will be BEER. Non-IP network with IP gateway and etc. Discussion. Are there any cases where current IPv6 address policy cannot cover? Other type of IT network need policy change. Which addressing should be caused in closed IoT network? Possible to assign global PI address ULI central.
So good day everyone. My name is Jeremy Bakiran. Today I'll be reporting media access control. So media access control. So what is media access control? A media access control is a network data transfer policy that determines how data is transmitted between two computer terminals through network cable. So ang media access control is yung tagatingin kung paano mag-transmit ang dalawang computers between terminals through network cable. So media access control is a sublayer of data link layer or DLL in the 7-layer of OIS or OSI network reference model. The essence of MAC protocol is to ensure non-collisions and easy to transfer of data packets between two computer terminals. So, ang trabaho ng Mac OS is nag-determine ng collision. Para mapadali yung pag-transfer ng data between two computers. So, ang collision is nangyayari lang kapag ang two or more terminal is nagkakasabay-sabay na mag-transmit ng data and information. So, classification of multi-access protocol. So, random access protocol. Random access protocol or contention methods. No station is superior to another. At each instant, the station that has data to send use a procedure to define by the protocol to decide. So, kapag magsesend ka ng data, kailangan muna ng procedure para mag-decide kung ang data ba na ito ay kailangang isend o hindi. It depends on the state of the medium. So, types of random access protocol. Number one is Aloha. So, Aloha is a multi-access protocol for transmission of data via a shared network channel. It operates in the medium access controlled by sublayer or MAC sublayer or of the Open System Interconnection of OIS model. So, dito mayroong two types ng Aloha. Ang pure Aloha at slotted Aloha. So, ang pure Aloha, in pure Aloha, the time of transmission is continuous. So, ang pag-transmit ng data sa Aloha is continuous. Whenever the station has an available frame, it sends a frame. If there is collision in the frame is destroyed, the sender waits for a random amount of time before transmitting. So, kapag ang frame daw is nagkaroon ng collision o banggaan at nasira, maghintay naman ang sender ng ilang oras para sa susunod niyang pagtransmit. So, unlike sa slotted Aloha is reduced number of collision o dito sa slotted Aloha is mababawasan yung pagkabangga-bangga dahil the shared channel is divided into several discrete time of interval called slot. So, a station can be transmitted only the beginning of each slot. So, dito maiwasan yung pagkakaroon ng collision dahil ang pang-transmit dito ng data is per slot. So, as you can see sa example, lahat ng slot may bakante. So, talagang maiwasan dito ang collision o pagkabangga-bangga. However, there can still be collision if more than one station tries to transmit and the beginning of the same time slot. So, magkakaroon daw lang ng collision kapag lahat ng station is nagkakasabay-sabay na nag-transmit ng data. So, carrier sense multi-access or CSMA. So, CSMA is a network protocol that listen to our senses network signal. So, ang CSMA is kaya niya ding makiramdam sa signal bago mag-transmit ng data. So, CSMA is implemented in internet network with more than one computer or network device attached to it. So, CSMA is a part of Media Access Control or MAC protocol. So, ang CSMA daw ay CSMA is kanyang makiramdam sa data kung ito ba ay mahina or malakas. So, in short, kanyang makibagay sa data na or sa network na kanyang nasagap. So, makikita dito sa example is sa signal ng A is parehas sa signal ng B. So, pinagpantay niya yung data na ay yung signal na binibigay niya sa both A and B. So, CSMA-D ay CSMA or CD or Carrier Sense Multiple Access Collision Detection. So, dito naman is a media access control or MAC protocol. Defines how network device responds when the two devices attempt to use the data channel simultaneously. So dito siya, so sa CSMA-CD, so siya yung taga-response. Kung halimbawa yung A at C nagkasabay na nag-transmit ng data, di magkakaroon ng collision sa gitna. Magre-response siya para tawag dito, i-update yung host A at host B na nagkasabay sila ng pag-transmit ng data. So the CSMA or CD rules defines how long the device should wait if the collision occurs. So pag ang dalawang data na yan, pag ang dalawang host na yan is nagkasabay ng pag-transmit ng data, parehas silang maghihintay ng ilang oras kasi nagkaroon na sila ng collision dalawa. So until ma-fix yung collision, hindi muna sila makakasend ng data. So help host to decide when to send packets on a shared network segment and how to detect collision if they occur. For example, kaya in a hub network, two devices can send packet in the same time. This can use collision. CSMA or CD enables device to sense. Na-sense niya the wires to ensure that no other device currently transmitting packets. But if the two devices sense that the wires is clear and send packets the same time, a collision can occur. So, nangyari dito is na-sense yung host A na clear yung cable, walang nagtatransmit ng data. At na-sense din ni host C yung cables na wala din nagtatransmit. So, ang nangyari, nagkasabay sila ng pasok ng data, so nagkaroon sila ng collision ng dalawa. So, carrier sense multiple access collision avoidance. So, ito is kabalitaran lang ng CSMA-CD. So, CSMA-CA is a protocol for carrier transmissions in 802.11 networks. Unlike CSMCD, which deal with transmission after collision has occurred. So, CSMA-CA act to prevent collision before they happen. So, in CSMA-CA, as soon as a node receive a packet that has been sent, it checks to be sure that channel is clear. No other node is transmitting that at the time. If the channel is clear, then the packet is sent. If the channel is not clear, the node waits for a random chosen period and then check again to see if the channel is clear. This period is called the back-off factors, and the is counted down by the back-off counter. If the channel is clear when the back-off counter reaches 0, the node transmits the packet. If the channel is not clear when the back-off counter reaches 0, the back-off factor is sent again and the process is repeated. So, makikita dito sa example is yung example number 1. Check the line. No carrier. Okay to transmit. So, dito sa number 2, nag-transmit yung host A. So, host A. Nag-check naman yung host 4. So, check to the line. Not okay. Transmit. please wait. So, naghintay yung host 4. Gaya sa hindi kagaya sa host 1 sa number 1 is nag-transmit siya dahil walang nagtatransmit na ibang host. So, controlled access protocol. Keyword nito is controlled, from the word controlled. So, controlled access protocol. The station consult each other to find which station is right to send. So, dito naman, siya yung nagko-control kung paano or kung kailan siya magse-send. Right send. Control access protocol grant the permission to send only one node at a time to avoid collision of message on the shared medium. So, ang control access protocol is yung nagbibigay ng mensahe sa mga host kung sila ay magse-send o hindi. So, station cannot be sent data unless it authorized by the other station. So, hindi ka makakasend ng data unless unless merong authorization sa ibang host. Parang ganun. Parang kailangan mo muna ng authorization. Kumbaga paalam na magsasend ka ng data para alam nila, para alam ng iba. So there are 3 types of control access protocol. Number 1 is reservation. So reservation. In the reservation method, the station needs to take a reservation before sending a data. The time is divided into interval. In each interval, a reservation frame precedes the data frame sent in the interval. So, nakikita naman dito sa example is 1, 2, 3, 4, 5. Okay. So, yan yung reservation frame. So, data. So, sa data station 1. So, merong 5 merong isang reservation. So, if there are n station is in the system, there are exactly n reservation mini slot in the reservation frame. Each mini slots belong to the station. When the stations need to send a data frame, it makes a reservation its own mini slot. The station the station that have made reservation can send their data frames after the reservation frame. So the following figures show a situation with 5 station. So yan yung 5 station. 5 station. And 5 station. 1, 2, 3, 4, 5. And 5 mini station. 5 mini slot reservation frame. In the first interval, so ito yung first interval, 1, 1, 3, and 4. Have made reservation in the second interval. Only station 1 has made a reservation. So ito lang yung may reservation. Dahil dito sa data station 4 is wala silang reservation dahil magkakadikit sila. So ang nangyari dito is yung data station 1 is siya lang yung may reservation. So pooling. Pooling works with topologies in one device is designated as a primary station and the other device is secondary station. All data exchange must be made to the primary device even the ultimate designation is in a secondary device. The primary device controls the link, secondary device is valid the instruction. It's up to the primary device to determine which device is allowed to use the channel at a given time. The primary device, therefore, is always the initiator of the session. Consider the figure. If the primary wants to receive data, it asks the secondary if they have anything to send. is called pull function. So when the primary wants to send data, it tells the secondary get ready to receive. It is called select function. So select function is ito yung function na use whether the primary device has something to send. So inaas niya muna sa mga host na magsesend siya ng data. And dapat ang host or yung mga host ay mag-reply sila sa primary para ang primary ay alam niya kung kailan siya magsasend ng data. So makikita naman dito yung example. So si primary nag-send siya or in-alert niya si host B na magsesend siya ng data. Tapos si host B naman sumagot siya na pwede siyang mag-send ng data. So si primary nag-send siya ng data and si host B naman is nag-reply siya na natanggap na niya yung data. So sa pooling naman is si primary is nag-a-ask siya kung magsesend siya ng data. Ask niya man yung kung magsesend siya ng data. So the pool function is used the primary device to solicit transmission from the secondary device. So nagsusolicit siya ng data. So si primary is nagsusolicit siya ng data o kumbaga kumukuha siya ng data sa host A, pero si host A wala siyang naibigay na data. Samantalang si host B, nag-solicit si primary ng data sa host B. Si host B naman, meron siyang sinend na data and si primary is nag-acknowledge siya na nakuha na niya yung data. So, token passing. In token passing method, the station in a network are organized as logical ring. In other words, for each station, there is a predecessor and successor. The predecessor is the station which is locally before the station in the ring. The successor is the station which after the station in the ring. So before and after. So the current station is one of the accessing channel now. So the right to this access has been passed from the predecessor to the current station. The right will be passed to the successor when the current station has no more data to send. In the method, a special packet called token circulates through the ring. The possessions of the token give a station the right to access and the channel and send data when the station has some data to send. It waits until they receive the token from the predecessor. And then hold the token and send it data. When the station has no more data to send, it releases the token, passing it to the next logical station in the ring. The station cannot send data until it receives the token again the next round. So token management is needed for access method. Station must be limited in the time they can have possession for token. The token must be monitored to ensure it has not been lost or destroyed. For example, if a station that has holding the token fails, the token will disappear from the network. Other function of token management is to assign properties to the station and to the types of data being transmitted. And finally, token management is needed to make a low priority station release to the token to high priority station. So logical ring. In the token passing network, station to station do not have a physical connected in a ring. The ring can be logical one. The following figures show the different physical topologies that can create a logical ring. In physical topology or physical ring topology, when the station sends the token to the successor, the token cannot be seen by the other station. So kung baga si station 1, nag-send siya ng token sa station 2 or data. Si station 3 and station 4, hindi niya malalaman kung anong sinend ni station 1 sa kanya. Ganun din kay station 2 at station 3. So sa kanila walang hindi nila malalaman kung anong mga sinend sa kanila dahil dito sa physical topology. This means that the token does not have an address of the next successor. The problem with this topology in that if one of the link, the medium between two adjustment station fails, the whole system fails. So pag nagkamali yung send ng isa, yung sinend ng isa is napunta dito ay nalaman dito, buong system na ang magkakamali. Next is dual ring topology. So ito yung dual ring topology. The dual ring topology is use a second. So ring is operate in the reverse direction with the main ring. So ito yung main ring niya, yung black. So yung pag-send niya ng data dito ay pag nasira pala yung main ring niya, pwede silang mag-send ng data na ay pwede silang gumawa ng pansamantalang ring para continuous yung pag-send nila ng data. The second ring is for emergency only. If one of the link in the main ring fails, the system automatically combines the two rings into a temporary ring. After the failed link is restored, the auxiliary ring becomes idle again. So in bus topology, and bus ring topology, also called as token bus, the stations are connected to a single cable line. So ito yung bus topology. So the dual ring topology use a second auxiliary ring which operate the reverse direction compared with the main ring. The second ring has emergency only. So if one of the link in the main ring fails, the system is automatically combines the two rings in the form of temporary ring. After the failed link is restored, the auxiliary ring becomes ideal again. So this is the dual ring. So sinabi nilang dual ring kasi pag nasira itong isa, pwedeng gumawa ng emergency ring para tuloy-tuloy yung pag-send niya ng data or circulation. So in bus ring topology, also called as token bus, the station connected to a single cable called as bus. They however, make a logical ring because each station knows the address of its successor and the predecessor for token management purpose. When the station has finished sending its data, it releases the token and insert the address of its successor in the link token. Only the station with the address matching the designation address of the token gets token to access the shared media. The token or bus LAN stands standardized by IEEE uses topology. So ito yung bus. Pwede siyang mag-send ng data sa host 4 o sa host 2. Pero gumawa din siya ng ring para makasend siya ng data sa yung host 1 sa host 2. Para tuloy-tuloy din yung circulation. So in star topology or star ring topology, the physical topology in star, there is a hub, however, the axis of the connector as the connector. The wiring inside the hub makes the ring, and the station are connected to this ring through the two wires connection. This topology makes the network less prone to failure because the link goes down. It will bypass by the network, bypass the hub, and the rest of the station can be operated. Also, adding the removing station from the ring is easier. This topology is still used in token ring or token ring LAN designed by ABM. So, ito yung by iStar ring. So, yung data, nag-send siya ng data, pupunta dito sa hub. And yung hub is, yung data, magtatransmit kung saan niya yung isang host niya sinend yung data. Para yung lahat ng data na sinesend nila is napupunta dito, magtatransmit doon sa kanilang stasyon. So, channelization protocols. Channelization is a multi-access method in which the available bandwidth of a data of a link shared time frequency through code between different stations. So there are three channelization: FDMA, TDMA, CDMA. So frequency division multiple access of FDMA. In a frequency division multiple access, the available bandwidth is subdivided in frequency band, which each station is allocated band and send it data. In other words, each band is reserved for the specific station and belongs to the station all the time. Each station also uses a bandpass filter to combine the transmitter frequencies. To prevent station frequencies, the allocated band are separated from the other by small guard band. The following figure show the idea. So, si host 1 nag-send siya ng data. So, yung data mapupunta dito sa to be called bandwidth. Yung bandwidth nakalagay doon, may kanya-kanya silang station. So, nag-send ng data si station 1 is na-store dito sa kulay blue ata. Ganon din si station 2 ay si host 2 nag-send siya ng data is napunta dito sa kulay red. Sa pati din sa kanila lahat. Meron sa kanya-kanya silang station. So division ay time division multiple access. The in the division multiple access or TDM station, share the bandwidth with the channel in time. Each station is allocated in a time slot during which can send data. So kagaya din doon, pag nag-send ka ng data is mapupunta sa respective color niya. Pero kung ano yung time mo na mag-send ng data, yun din yung time na mapupunta dun sa o ay sa respective station allocated. So the difference between TDMA and TDR TDM is a physical layer technique that combine the data from slower channel and transmit by using a faster channel. The process uses a physical multiplayer that interleaves data units from other channels. TDMA, on the other hand, it is an access method, the data link layer. The data link layer in each station tells the physical layer to use the allocated time slot. There is no physical multiplexer at the physical layer. So, code division multiple access. CDMA simplify means communication with different codes. CDM refers from CFDM because only one channel occupies the entire bandwidth of data of the link and differ from TDMA because all stations can be send data simultaneously. There is no data sharing or there is no time sharing. Implementation. Let us assume the 4 stations. So 1, 2, 3, 4. So 1, 2, 3, 4. Connected to the same channel. So nakakonect sila sa isang channel. So the data from 1 is D1. So host 1. Ang data niya is D1. Host 2, D2, D3, and D4. Host 3 and 4. So ang code naman ng S ay ng host 1 is C1. Followed by host 2 is C2 and C3 and so on. So we assume that assigned codes have two properties. So if we can multiply each code by other, we get 0. So pag minultiply mo ito, kukuha mo 0. If we multiply each other itself, we get 4. The number of stations. So makukuha natin yung number of station pag pinag-times natin itself. So with the sense of with these properties in mind, however, above the 4 station can send data using the same common channel as shown in the figure. So makukuha natin yung same na data nila. So next. So station 1 multiplies, special kind of multiplication as well as multiply its data by its code to get D1 times C1. Station 2 multiplies the data its code to get D2 times D3 and so on. The data go on to the channel and the sum of this term as shown in the box. So ganito yung magkakalabasan. So any station wants to receive data from one of the other, 3 multiplies the data on the channel by the code. of the sender. For example, suppose station 1 and 2 are talking to each other. So station 2 wants to hear what station 1 saying. So it multiplies the data on the channel by C1, the code of station 1. So because C1 times C1 is 4, but C2 and C1 and C3, C2 times C1, C3 times C1, and C4 times C1 are all zeros. Station 2 divides the result by 4 to get the data from the station 1 data. So, ganito yung mangyayari. D1 times C1 plus D2 plus C2 plus D3 plus C3 plus C4 ay D4 plus C4 ay times C4 times C1. So, ganito yung kalalabasan. C1 times D1 times C1 plus C1 times D2 times C2 plus C1 times D2 ay D3 times C3 plus C1 times D4 times D4 is equal to 4D1. So, chips. CDMA is based on coding theory. Each station is assigned a code which a sequence of numbers called chips as shown as the following figure. The codes for the previous example. So, ito yung codes niya. Ito yung example niya. Next. So, we need to know that we did not choose a sequence randomly. They were carefully selected. They are called orthogonal sequence and have the following properties. So, 1, each sequence is made of n elements, where n is the number of station. So, number of station is 4. If we multiply the sequence by the number and every elements in the sequence is multiplied by elements. So, this is called multiplication of a sequence by scalar. For example, 2 times plus 1 is equal to, ganito yung kakalabasan niya. 2 times positive 1 is positive 2. 2 times positive 1 is positive 2. 2 times negative 1 is negative 2. 2 times negative 1 is negative 2. So, if we multiply 2 equal sequence elements by elements and add the result of, we get n, where n is the number of elements in each sequence. This is called the inner product of the two equal sequence. For example, so positive 1 plus positive 1 is equal to positive 1. So, positive 1 plus positive times positive 1 is equal to positive 1. Negative 1 times negative 1 is equal to positive 1. Negative 1 times negative 1 is equal to negative 1. So, we get 4. If we multiply two different sequence elements by elements and add the result, we get 0. If they call the inner product of two different sequence, for example, positive 1 times positive 1 is positive 1. Positive 1 times positive 1 is positive 1. Negative times positive is negative. So, negative 1. So, negative 1 times positive 1 is negative 1 to get 0. So, number 5, by adding two sequence means adding the corresponding elements. the result is another sequence. For example, positive 1 plus positive 1, positive 2, positive 1 plus positive 1 is positive 2, negative 1 plus positive 1 is 0, negative plus positive 1 is 0. So data representation. We follow the following rules and encoding. If the station needs to send 0 bit, it encodes negative 1. If it needs to send 1 bit, it encodes positive 1. When the station is idle, it sends no signal, which represents as 0. Encoding and decoding. So as a simple example, we showed how 4 stations shared the link during 1 bit interval. The procedure can easily be repeated for additional intervals. We assume that station 1 and 2 are sending 0 bit and channel 4 is sending 1 bit. Station 3 is silent. So nag-send siya ng 0 bit. So, negative 1. So station 2 send siya ng 0 bit, negative 1. Station 3 is silent. And station 4 is nag-send siya ng 1 bit, so positive 1. The data at the sender site are transmitted to negative 1, and 0, and positive 1. Each station multiplies the corresponding number by its chips, which is unique for each station. The result is new sequence, which is sent to the channel. For simplicity, we assume that all stations send the result sequence at the same time. The sequence on the channel is a sum of the 4 sequences. As defined before, the following figure show the situation. So, ganito yung mangyayari. So, yung result ng kanila ay yung result ng kanilang sequence is ito. Ito na yung naging result niya. Yung result nilang 4. So now, imagine station 3, which said is silent, is listening to station 2. Station 3 multiplies the total data of the channel by the code to station 2, which is positive 1 minus negative 1 plus positive 1 minus negative 1 to get negative 1 times negative 1 minus negative 1 minus negative 3 plus negative 1, so negative 4. So positive 1 minus 1 plus 1 minus 1 is 4. Is equal to negative 1 repeat to 1 bit. Is equal to 1 bit. So sequence. To generate chip sequence, we can use Walsh table, which is 2-dimensional table with an equal number of rows and column as shown as the figure. So ito yung Walsh table. In the Walsh table, each rows is a sequence of chips. W141 chips sequence has row the column. We can choose negative 1 or positive 1. So ito W1, so pinili niya positive 1. So for the chips, this tribal table, we can choose positive 1. So according to Walsh, if we know the table for n sequence, Wn, we can create a table for 2n sequence or W2n as shown as the figure. The Wn with the overbar, Wn stands for complement of Wn. There is positive 1 starts to negative 1 and vice versa. The figures also show how can is created W2 and W4 forms from W1. After selecting W1, W2 can be made from 4 W1s with the last one. The complement of W1 after W2 is generated with W4 can be made of our W2s with 1 plus 1 of complement of W2. Of course, W8 is composed of W4s and so on. Note that after Wn is made, is stationed aside the chips corresponding to a row. So, ito yung example niya. Something we need to emphasize is that number of sequence n needs to be a power of 2. In other words, they need to have n is equal to 2m. That's all. Thank you.